Hello, hello. So we are going to spend we've got 30 minutes before the next meeting, and I want to fit in a little bit of work around index wallets. The place that we left off last, if I make myself small enough here, was this update function. And so we're just going to turn this into a 30-minute planning working session in order to find a path for the update function. So here's the update function. And to give context, what we have here is a player that is making some choices in the market about how much to sell their products for. And they know that they're not going to be able to make a sale if they don't have the best price for a customer. That's our criteria right now. And so what we imagine is probably true for any individual vendor is that they have this this landscape where in a competitive environment, they have some amount of revenue from a particular set of customers when the price is low. Actually, probably it looks more like this. When the price is low, they can raise that price, and maybe they actually, I guess probably it would look something like this. They might be able to raise that price, and then maybe one customer drop off to a competitor, so they would lose them, and then they can keep raising their price, and maybe they lose some more customers, competitors, and they can keep raising their price, and then there's some point where they kind of top out, and now that was an accident, and now the price begins to go down. And maybe if they raise their price high enough, then their total, let's talk about revenue right now. Revenue tops out along with it, somewhere around here. Okay, so that's the first part of the story. It turns out, though, that this price is more high dimensional in our world than in just there's at least two things to pay attention to. There is the what we call the expected revenue from a sale, or let's call it we can call it the revenue on sale. In our code, we also call it the need, so the amount of money that a player requires, a vendor requires in order to make the sale worth it. Any particular customer can be anywhere in this high dimensional space of tokens. So they can say that they highly value token B, they can say, or currency B, or public good B, or they can highly value public good A, or they could highly value both of them, or they could lowly value both of them, right? And there are multiple customers, so we can just arrange them like so, and maybe it looks something like this. I don't know. So here's our landscape, and all of this information comes together to spit out on the other side the price for the customer. And so we have to, in order to figure out the total revenue that should pop out the other end here, we have to figure out where to position ourselves. So let's make a little this is going to be our indicator for a player's. This is our vendor, and they have to place their valuation somewhere in this space. And depending on where they place their valuation, there's actually, there's two components to this. There's where they place their valuation, and then there's their need. So let's say how big this circle is. I'm trying to think if there's if there's a way that we can visually communicate all this information at once on one graph. I think that maybe the closest we could do is you can have, so we'll make our player green, we'll make our competitor red, and it might actually be kind of useful to put some numbers to this. So let's go ahead and do that. We have a bunch of players. Player A, B, C. How many do we have here? D. And then we're going to have two vendors. Okay, so this is going to be, that's the only one I don't need to change. D, and then you're going to have me and a competitor. Okay, and they need to know their valuation and their wallet. Right. No, their valuation and their demand. For now, we're going to simplify things because we're going to assume. So let's write some documentation that says vectors. Why is it always in that form? It's really annoying. Present the vectors represent the valuation of a player. All players are assumed to have equal demand for now. Okay, so that is our world. This over here should say something like vendors. These are squares, represent the valuation of a vendor. The area of the square area okay. Need is the amount that they need to take home. If you've ever negotiated with like if you walk into a small business and you say, honestly, these are pretty expensive. Is there anything you can do on the price? They say, that's what I need to charge. That's what we mean by need. Need is an expression of, stated constraint. And it might be, at that point, the best that you can do is you can walk away and maybe they'll get the message. Okay, so player A, B, C, D, I guess this is something like, it's sometimes useful to work these visual examples. So let's do that. So there is A, we're going to say that that's like 8 and 3. Here's the middle point. Oh, that's like, let's see, so that means this is a unit of 1 then is like, that's 1, 2, 3, smaller than that. There's a unit of 1, 2, 3, 4, 5. And in theory, oh, yeah, that's right. 5. Great. Useful to have markers. Okay. And we'll use the same scale down here. Oh, well, that would explain some of it. I guess this should be something like that. That can be there. Okay. This will make it easier. So let's just go ahead and make that. We'll make this one 9 and 3. Wallets on these are always going to be and 10. It doesn't really matter because we're not. So this is wallet. Let's do next player. So you are going to be, B is 8 and about, let's say it's 8 and 8. 8 and 8. 1, 2. This is about 2 and 7. And we'll do 1 and 9. So there's the valuation of all of our different players. Now we need to figure out how to set the valuation of these players here. So where should I put myself? I'm going to try putting myself at well, the question is, what do we mean by at? So I'm going to make these little diamonds. Let's see. Because I think when they're diamonds, it's a little clear that they're a little bullseye. And where am I going to put this? I'm going to put it at, let's try it down here. So 8 and up here at 2, let's say. So valuation 8 and 2 and valuation. That's probably fine. 3 and 7. Okay. So we have built up our example, and we now want to try to visualize the we'd like to kind of imagine moving these people throughout the incentive landscape in order to let's see here. In order to help them maximize their, I think we're going to start with revenues, and then we're going to eventually have to make our way to profits. Revenues are just easier to calculate. Very ragged. But I think this will look a little nicer. Range line, bottom. Yep. Yeah, much better. Great. Okay. Range line top. Okay. We can take this now, and we can also go ahead and replace this over here. Beautiful. 1, 2, 3, 4, 5. We will label it. Let's center it. And let's make it smaller. 7, 8, 9, 10. Just checking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. All right. Okay. So, I think this is also useful here for some reason. Invest in your tools is what I will say to you. Like, for example, this is more useful than knowing 10. Okay, so we have a kind of beautiful little graph here. Now what do we want to do? So now we can calculate the a.wallet.index over to me.valuation.value a.valuation. So this should give us the amount, right? And then we need the amount. How are we going to do amount visually? We're going to say, I said that the area. I don't think it should be the area. I think best idea I have is it should be the diagonal. So let's do that instead. So it's going to be, we'll use this as our unit. This is going to be price of 1. Let's not start with the price of 1. Let's start with the price of 2 and put it back at comp 37, me 82, 37, 2, 3, 2. Okay, so that goes there. That is fine right there. So they have the same price. They're both going to be need. We call these needs. And let's go ahead. Well, so this should pop out. Meetup valuation. Meetup valuation. Okay. That's wrong. Meetup wallet. Huh. Okay. Name. See, this is why I don't like putting names in here as arguments. I don't like it so much that instead like what you want is a programming language that has this kind of meta awareness. It understands the name here and it's able to capture it. I think that Python has like a facility to do this, but it's really inconvenient if I remember. Is there a way to get the name of a variable? Maybe like you could do maybe there's an F string. Maybe there's an F string or something like that. Now what do we want to do? We don't want this to work like this anymore. Sorry. This is going away. Okay, right, but see, this is the other thing. In Rust, you could do this. You can have a variable that is, or a method that is that is distinct from an attribute, but that has the same name. I want to use a different term than name, but you get the idea. So you could do this, but we can't do this here. So we're going to have to call this underscore name, which is, of course, tragically ugly. And this should now allow us to, okay, great. Value of a dot valuation returns an index. What if we just did dot? Why does value return an index? Did I edit this? S times, yeah. As type float. Okay. So now value. I don't know. If you don't want it, you can just do dot. You can just do dot, but okay, so that is going to give us our like the price according to A. And we can now do this for everyone. So let's do a function called price. Let's say the customer is the first argument, and the vendor is the second argument, and I guess the need is the third argument. And we're going to return this, which should be customer, now vendor, need, customer. And really hate that it returns an index, so dot it is. Let me just check if there's any other way to. It's really annoying. I think maybe you can just do as. Or two. Sometimes it educates me when I want it to just give me the fucking solution. Okay, I guess I can do this. No. That's so annoying. All right, we're switching S dot valuation. Turn. It's the same operation, but it gives me the thing that I want. And I can use value, which I think is a little easier for people to. This is just more transparent. A, me, 2. Should be 2.4 again. Okay, great. So we have 7 minutes here. Let's just now loop through the let's make some objects. My offer, comp offer, two, and we're going to say for offer, in offers, I guess it's fine. We can say in my offer comp offer for customer in A, B, C, D. Go ahead and build up for us a result. Prices should be something like an object like this. And this will be 4-player. Ah, shit, we need them to have names now. Okay. Okay. So, I think we're good to go. If we put our customer here, and this should be vendor need, and this should be customer vendor need, and now we recurse infinitely. What? There's no recursion. Oh shit. I bet. Maybe it's the naming stuff. No, it's not the naming stuff. Ooh, okay. Okay. For some reason, appending prices causes it to recurse forever. Because whatever. That causes it to recurse forever. Ah, right. Look at the errors. Look at the errors. When it shows you an error, just look at them. Okay. Okay. We have our prices now, and now we can do something like pd.data frame columns should be and data prices, and this will be customer and price. Great. Customer vendor, I think. All right. So this is similar to, this is exactly like the kind of data that we're getting in wherever that is. So we have customer vendor price. We've just done it on this little micro scale. And what we would like to do is I guess, how can we visualize so A to I have to go. I'm out of time. The next step is going to be to try and visualize each of these prices with respect to these players. And if we can do that, then it will make it'll make a lot of sense. But for now, I'm going to get ready to jump on a call. And once the person shows up, I'll leave. Where? Here, I think. Okay. Okay, so what are we doing while we wait for people to show up? Well, okay, the ugliest thing to do, which is a good place to start, is draw a little line here. Like so, maybe? Oof. Actually, it's bad, but it's a start because we now need to do prices. So from customer A, we never labeled these. A is up here. B, C, and D. From customer A, well, let's do let's do B first, I think, because it's easiest to label. B to me is 3.2. So let's mark out 3. There's 2. There's 3 and there's 0.2. Okay. There's B. And then B to the competitor is also 3.2. Well, that seems surprising. Really? No, that's not right. Something is not right. What's the first? Yeah, something's not going right. But I clearly have to go. Something's not right. We'll figure it out. Okay, bye. Okay, great. It's after 5 again, and we can. Oh, I just dropped my pen. We can get to work on this project again. So, where we left off was we have computed this table of customer, vendor, and price, and we drew this horrible picture over here that is trying to indicate, I guess maybe let's make this like perpendicular here, I guess. It's trying to indicate, if this person were to buy from this person, how much would it cost? And we see some weirdness, which is that somehow the prices are the same, which does not make sense. So price, customer, vendor, need. Customer, vendor, need. Those are the names. Oops. Print. Yeah. Okay, I'm back. So something is wrong. That's all right. Let's print it. So this should be print customer.wallet, print vendor dot, and print customer valuation. I wish it was easier to write F strings. I mean, it's like really not easy. F, this, oh shoot, then this, and then go to the end, and then this, and then this. Oops. Okay. Okay. Yep. There's your wallet. Here's your valuation. Oh, right. Right. This is not your okay, where's me? This is not your valuation. This must be your wallet. Ah, right. So this is so we're kind of superimposing two graphs here. This might be a mistake. Just in case, let's also put one down here. And then let's put this over here. And on this side, let's do this. And on this side, we think you will be me. This is the competitor. So, right. Mm-hmm. So the customer's valuation does not matter because they are the customer. So what should be happening is Okay. There we go. There we go. So this has to be, this is wallet space, and this is valuation space. I really wish it was left aligned by default. Okay, now what? Well, now we have our prices and whatnot, so I think we have discovered the issue. Does Wallet have a get price function? No, it doesn't. I don't know. That might be useful. I can't tell. Cannot tell. Okay. Well, this creates some vector field. So up here is A. And at A for the competitor, it's 0.5. Where 0.5 means we're overlaying. Yeah, this makes sense. I might not be communicating it well yet, but yeah, this makes sense. B is 0.4. So where is B? It's out here. Oops. Sorry. B is 0.4. C is 0.37. So like somewhere around here. D is 0.303. Somewhere around here. And I guess all of these should be like matching red. Okay, cool. Yeah, okay, this is cool. This is useful. Next, let's do A. So now A over here. So we've got, I'm going to just write them down. Well, it doesn't really matter. A is 0.3. B to me is 0.4. C to me is 0.6. And D to me is 0.769, so 0.77. Something about this feels wrong. Why is it that the thing that's further away feels... Did I get the arguments backwards? Maybe. I'm 8, 2. 8, 2. Oh, and then you are 3, 7. Okay, that makes sense. So I need to transpose this. 3. So I'm 8, 2. And you are 3, 7. One, 2, 3, higher. 7. Cool. That makes more sense. Best deal is here. Okay, so then we can do... It's interesting that that's tied. This is cool. This is really cool. Makes me want to get TLDraw, like start programming with TLDraw. As like a visualization tool. What's it like? Oh yeah, I forgot about this. All the praise TLDraw gets is so deserved. It's just unbelievable. So deserved. Beautiful graphs here. GitHub, such good information. Such a great product. What audacity to compete with GitHub. Gitbook comes along and tries to improve on this. It's fucking Very cool. Look at these ducks. Fuck, man. Dang. How do they do this? How do they do this? I mean, this is crazy. It's so cool. They're having too much fun. See, this is what I want. This is fucking cool. That is cool. Oh. What is this? Oh, it's a spline. What does floaty window mean? these would move. That's so ugly. That's cool. I was showing someone that you can look up songs just by like putting in pieces of the lyrics. In the future, that will seem like such an anachronism. Like, duh. Of course, the AI has infinite knowledge of everything. Yeah. What do we put in here? So, looks like even ChatGPT can help. Can I move shapes around and that cause other shapes to move? Okay. It's going to tell me, like, I'm sorry, I cannot read links. Yes, you can. You can do it. We believe in you. All right, where are we? We were trying to. We didn't want to have to handwrite these, and so we were trying to distract ourselves with a multi-day project. The primary thing you learn as an engineer is to do less of it. Don't do so much software engineering. Do things manually. Okay. So, oh my gosh. It's been a crazy day. What do I want to know now? Well, so I'm just going to mark each of these with who won. Green one, question mark. Red one. And red one. So now what we would like to see is, so far this teaches us something. So it teaches us that there are two input spaces, wallet space and valuation space. And that as a result of this, as a result of these two interacting, you get this output. Which is this multi-layer price object for each competitor. So competitors put their information in the valuation space. That can be one. This has to be, I guess, a matrix. This has to be a matrix. And then through some transformation, you can produce this. So that would be a cool thing to figure out. What is the transformation that produces this structure? That is annoying. Okay, so we have our wallet matrix. We have our valuation matrix. We have some function which accepts both of those. We would love to find this function. And output. Okay. Okay, and what's in here? What's in here is So is this denominated in well, it's going to be vendors times it's funny that that's the same. So this is vendor by token. This is customers by tokens, really players. Yeah, it's got to be customers. Otherwise, we don't care about it. And then this one, we could call, it needs a name. It's also a matrix. And it is going to be tokens, we know. No. Well, it's just customer by token by. That's what it is. Customers by tokens by vendors. Okay. Ordering normally matters here. I can't remember what order you put these in. If it's row, then column, or column, then row. But you get the idea. So, it might not be right to call these vendors. These are competitors. It's not all vendors in the space that you need to compute. It's just the competitors selling the same product. Cool. So we in other words, this might be the red, this whole space. This might be the green. This might be another competitor, and so on. Cool. And then we can take this, and for each vendor, we can compute a expectation, right? Yeah, it's probably fine to think about it that way. Oh, I don't know where this. Somewhere in here, we need to also put a need. I don't know if it's a plus, but yeah, it has to go in there somewhere. And then for each of these, we compute an expectation. Oops. Okay. Oh, 1 second. Okay. So we're plowing through the water here. Matrix by tokens by or customers by tokens by vendors, and somehow need gets in there. No. Need goes in here, right? Valuation matrix and needs. Let's do it like this. Beautiful. Perfect. Not even vaguely misaligned. Is that better? I don't know. That's better. Oh, that's nice. Okay. Okay. Great. Now what do we do? Well, whatever this function is here. Okay, so we need some g of this that then goes out here. So this function is probably pretty simple. It is yeah. It's probably just some process by which you're just finding the min. You're finding the index of the min. So if the min is on layer 2, then that spits out down here a 2. Now you can't see what I'm drawing, but and so you get a final matrix. You've just done a dimensional reduction. Nice. Wait a second. So you have your wallet matrix, you have your valuation matrix. Your Your wallet matrix. No. Why would you need tokens here? Why? Okay. Why does this need to be three-dimensional? Why can't it be two? Input valuation matrix. Output. Yeah. Why do you need? Oh, you're computing the. But then if you do that, you don't need the customers. I think we don't need customers here. This is competitors buy tokens by Lang customers. All of these are length. But what's so hard about this? So let's just say, let's label these then. Let's say this direction is prices. Now let's have them be, vendors. So each vendor in a row or in a it gets their own column. Each up this way. So let's just make that clear. These are rows of vendors. Up this way, each, so you have these rows of vendors. What's in each row? A price. And no. So I'm now going to know that this means size of each of these, not literally these, because this is not going to be that. This is going to be this vendor. So then what should this be? I think it should look like this. Okay. So we're going to pick a vendor, say me, say competitor. We're going to swap these. I'd prefer to think about myself, of course. We're going to pick a competitor, in this case, me. And for every single, that's not how this will work. For every single token combination, That is not tractable. Oh shit. Right. I forgot. Well, no. This actually can be a matrix because literally your here it looks like um, it looks like vendor with columns. And then tokens as rows. So yeah. Right. And so then there's going to be some valuation for each token. Can I please rotate this? Or value given to each token. So actually, you could call this a, yeah, that's fine. Okay, fine. So that can be a matrix. Okay, so that can be a matrix. That's great. This. What do we do with this? Um, so each vendor no, I don't want that. That sucks, man. It's not computable. It's not computable. It's too bad. Feels like it should be obvious in retrospect that it's not computable, but the problem is that we actually need times the reals because Yeah. Bummer. Hmm. Each of these can be high dimensional. Fuck, that's not gonna work. Okay, what do we do then? Um, well, that's just if we want to sample all. No, okay. So if we instead of thinking about this, right? So far, I've been thinking about this as like what we could consider the competition matrix, and that's certainly intractable. But if we instead say the and or like the no, let's say that the other one we'll call um, the possible competition matrix, but this is the simple competition matrix, and okay, now what do we do? Now, what do we do? So now what it tells you is basically who's going to win. So the purpose of this matrix is who is going to win the business. Hmm. So you have all your little things in here that say, what is the price at each of these? Did I have this? Yeah, price. The entries, we might call it price. This is for, so for each, yeah. You shouldn't do that for each token. Or should you? Let's see. So in this case, would it really just be as simple as A and B by So A and B repeated down here. Vendor A. Let's say me, you. And then and then it's customer. Mm-hmm. So this is basically what this was. But what is the token thing doing for us? Vendor? No, because this is the product. This is not right. Well, I keep oscillating because I've put weird things on here, but we're just saying right now that as we look in the space, how's this look? As we look in the space, if we go further out this way, the price goes down for somebody, and oh my gosh. Now, if we had a third token, we would have a volume. Yeah. And when we have thousands of tokens, it's going to be a massive space. And then you're going to have each of those is going to be high dimensional for each one of those. We can't do that. We cannot do that. We cannot do that. So we have this hyperobject. It has as many dimensions as the number of tokens times the number of vendors. Yeah. So we do not want to compute this. What we want to do what we want to do is, okay, this is great. This was really productive because all of this is garbage. You had no idea that it could be so productive to just roll something out. Let me draw a little mouse here. Oh, that's so bad. Come on. Boom, boom. Good. Better. And then the trick is you draw it big and then you scrunch it down. And it looks like you're very talented, but you're not. You just did it in high fidelity and then shrunk it to low fidelity. And everybody's confused. Okay, so what we do is we pick one of these pairings. We say, click, tell me about how I could win. So how could green win in this case? And what should be the case is that there's some shape to be drawn over here, probably a line. that shows you the set of valuations that would allow you to be competitive. I don't know exactly what that shape looks like, but we can guess that well, maybe it's a curve. I can't remember. I can't quite we can compute this, right? We can take our let's do something really ugly. For x in range, let's call it for a. For a in range up to, looks like we like go up to 10. For a in range 10, b in range 10. If the so let's do results data. Oh, you're doing your favorite thing. So we are if we imagine a world, let's just pick one player. Okay, we're going to call this capital A so that we don't get confused. Capital B, these are our tokens. If player valuation was A, B, then, and wallet was wallet, because it doesn't matter. Okay, so if price of, let's do customer A versus me versus alternate, with whatever the need is that we were using up here. I think the need was 2. Is less than price of me, then data.append, and we want to append, I guess, the A, B, Okay. And now we should be able to px dot scatter. X should be equal to 0, y should be equal to 1. Color should be equal to 2. Okay. Okay, nice, we did it. Now let's try and up the. Oh, look at that. So it's a pretty interesting. Oh God. Oh God. Oh my gosh. Optimizing this fucking thing is gonna be really hard. What the hell? Oh shoot. Okay, well it does look like a line. Let's do mp dot what's it called? A range? 1, 0 to 10. Something like this. Does that work? Yeah, it works. Let's do the same thing here. I mean, it's coming out pretty clear, but this will be slow. Probably too small of a step size. Probably too small of a step size. Definitely too small of a step size. Yeah, okay, let's stop. Oh, it happened. I'm not going to interrupt it, but too small a step size. Definitely a line. Until this point. Oh, dear God. It's completely frozen. Oh, please stop. Kernels are broken. They're in a very failed state. It's nice they added Git. That's really nice. Okay, we might have to go open up a new Jupyter. Oh dear. Oh, okay. We're back. All I wanted to see was if oh, everything is frozen. My gosh. Oh boy. Oh boy. We're back. You probably are watching this from we've lost. It might be time to take a break. Maybe time to be done. We have we've shown that it's linear and that we might be in some optimization trouble figuring out because we're going to have a bunch of these. I really would like to finish this up, but I think that we are. I think we're out of luck, and I don't even know if. Oh, this is working now. Okay, so long story short, we found out that this is a line. That when we look at one of our competitors, we can find out where we would need to be in order to beat them. If we did that, then that would tell us our expected profit. We should focus on revenue. Revenue from making that move. And I suppose after many of these, we could build up a, kind of this Pareto optimal front that said, if you were to, place your new valuation here, this is all the revenue you would gain. You would have to do that for every customer. So draw these lines for each customer, and then that would neatly partition them, and you would know expected revenue, assuming that your competitor does nothing, which I think is the assumption that we should start with, because otherwise it's going to be way too hard to compute. Are you done over here yet? It's crazy. Cool. Yeah, so there's only a couple of junctures you would need to check. Whew, this is hard. This is hilarious. Is there an easier way to do this? Yeah, and then you could just do minus the expected loss in purchasing power. And I suppose you could do, like later on, you might do some probabilistic expected revenue instead of just like this naive expected revenue. So let's actually notate that. Cool. Well, I think that's some progress. For every customer, every customer's location, you compute their you compute this vector. It's just a vector now. Amazing. That says where your valuation need to be in order to be competitive. You then you do that for each of them in order to figure out what would be your revenue maximizing move. And then what? Um, mm-hmm. Oh, we lost me. All I was gonna say before I finished up is that what this will tend to produce is valuations that flip flop. I can't tell if that's a problem, but it arises from the fact that in every turn, if there's just two competitors, then competitor A is going to move to be closer to the oh, by the way, this is in the wrong place. Should be outside of this, right? Because this is the zone of competitiveness. So, yeah, this competitor is going to change evaluation in order to get as many customers as possible. While this competitor does the same, which will probably sometimes cause the two of them to sort of flip. Let's see. And then if we don't have constraints, then they'll just both end up in the top right corner. So we're also going to need to build in constraints. And that'll be cool. I mean, I think this all makes sense. This makes a lot of sense. All right. That was productive. I gotta go spend time with some people that are showing up. Okay, I think this makes sense. That's exciting. Goodbye.